This is 7-7 factoring special cases. Well, case one is perfect square trinomials. And just the title alone should kind of give it away. So we're talking about perfect squares. So like 2 times 2, 3 times 3, 4 times 4, perfect squares. So first and last terms are perfect. So that's the first requirement. So here's some examples. So look at all of them. There's a 1 right there, and there's a 49. Those are both perfect. 1 times 1, 7 times 7. That's a 9, that's a 25. 3 times 3, 5 times 5. That's a 4, that's a 9. 2 times 2, 3 times 3. So the first and last terms are perfect. Check. It's also a trinomial, so check on that, check on that, check on that. They're all trinomials. And then the middle term is twice the product of the first and the last. So, and really that should say the first and the last of the binomial. So once you start factoring this, because you can literally, if you go straight to the factor, this literally, you don't really need to do a lot of work for this. You know that the first term, x times x is going to give us 1x squared. And then the last term is 49, so 7 times 7. And notice everything is perfect. And the way to check this, again, if the middle term is twice the product of the first and the last. So if you look at the first one, 1 and the last is 7. So again, this really should say of the binomial, not the trinomial. So if you take 1 and 7 and multiply those, that's 7. And then twice that's 14. And notice that's what the middle term is. Another way to simply do it is just double check by foiling. So if you foil this 7 times 6, and you'll see that it does equal the trinomial. So again, let's go to the next one. Do the same thing. We notice it's a trinomial. We notice that the first and the last terms are perfect. So 3x will give me the 9x squared. And then the last term is 25. And the way to get that is 5 times 5. Now, you need to be careful on this because a lot of students they'll mess up the signs. If I put plus signs, okay, when I multiply that out, it does give me 9x squared and it does give me positive 25, but it doesn't give me the middle term, negative 30. So that's why it's important to double check and make sure the signs that you check those are there. And so both of these will be minus signs to be able to do that. And again, if you FOIL this, 3x times 3x is 9x squared. 3x times negative 5 is negative 15x. Negative 5 times 3x is negative 15x. And then negative 5 times negative 5 is plus 25. And notice the two middle terms add together to give you negative 30. That's why they both have to be negative. So notice a short way of writing this, and something you need to pay attention to, this is actually x plus 7, and notice it's being repeated 2 times. So you would write it like that. And so the same thing, notice these are identical to each other. So 3x minus 5, and then being repeated. So the same thing here, we're going to have 2 sets of parentheses. Notice the first term is 4x squared. That would give us 2x. And then the last term is positive 9. So that would give plus 3. And again, I know it's plus 3 because the middle term is positive to be able to do that. And again, notice these are identical to each other. So it would be written like that. So that's case number 1, perfect square trinomials. And before I show you the next case, I want to emphasize again, make sure you check it by foiling. Okay, if you FOIL it, you can check your answers on all of these. All right, case number 2, the difference of 2 squares. Notice difference is referring to a subtraction sign, and so we have the difference of 2 squares. So again, the perfect squares, if you look at the first one, that's 1 times 1, and then 8 times 8. 1 times 1, 3 times 3. 2 times 2, 4 times 4. 4 times 4, 5 times 5. So they are still perfect squares, but I want you to notice that these are binomials with a subtraction sign. So they're still going to be the exact same thing. You know, we still have x8, 1 and 64, so that's how I know it's x and 8. But one's going to be a plus and one's going to be a minus. And so if it's a perfect squares, but if it's a binomial with subtraction signs, then one's going to be plus and one's going to be minus. So this is going to be x, this is going to be 3, 3, one is plus, one is minus. Again, to get the first term, that's 2x, 2x. To get the last term, that's 4, 4. And then one's going to be plus, one's going to be minus. To get my last example on this, the first term is 16, so that's going to give us 4x, 4x. And the last term is 25, that's 5, that's 5. One's plus, one's minus. And then finally, similar, I covered this similarly on the last video. Completely factor means you need to first, you should always, in every scenario, always ask yourself, is there a common GCF? Is there something common with all of those? So, like on this first one, we have 3 and 12, so we know what's common is a 3. And then notice the x's, what's common is 1x and then 1y. So that is my GCF. So when I factor that out, again, if I divide this by 3xy and divide this by 3xy, what remains? I have an x minus 4y squared. You better do that. Okay, and that right there is our final answer to better do that. I do want to point out something. If this was a cubed, then this would be a square. Okay, and then it could be factored out even more. So then this would factor to xx, 2y, 2y, and then again, notice it's a subtraction sign, so 1's plus, 1's minus, because it's a binomial. They're perfect binomial with a subtraction sign. So all of this, after you factor out the GCF, all of that is your answer. So let's look at the next one. So look first for the GCF. What's common between all of that is a 4x. And then when you factor that out of all of them, again, divide this by 4x, divide this by 4x, divide this by 4x. What remains is x squared plus 6x plus 9. And this can be factored. Again, always write your GCF to x plus 3, x plus 3. Or you can write it this way as well. And then finally, our last example, the GCF from that would be 2 y. Oh, there's no y in there, just plain 2. So once I factor a 2 out, I'm going to get 25 x squared minus 16 y squared. And again, I want you to notice, can it be factored more? Can it be factored more? Well, I notice that's perfect. I notice that's perfect. So this can be factored to 5x plus 4y and 5x minus 4y. Don't forget the GCF. So all of that is part of the answer. The 2 is part of it, and all of that factors completely down to that. That is your final answer. It's the same thing as this right here. And the way to check it is if I foiled this, if I foiled those 2 parentheses, and then multiply everything by 2, then it would equal this right here. It's a good way to always double check your answer.